join this webinar on System Modeling Workbench. I'm very excited to share with you the news we've planned to share with you today. System Modeling Workbench, most of you know what the System Modeling Workbench is, but just a short summary. Two strengths. System Modeling Workbench is based on Capella, developed by Thales, and the second strength is the integration with Teamcenter PLM. So today we are going to focus on this, second area, the System Modeling Workbench integrated with Teamcenter, and we will see, many new capabilities, that are very exciting. All right. So, did you know that a significant portion of a project lifecycle costs are committed very early in the concept design phase? So based on an INCOSE analysis, around 70% of these design costs are locked in during the first 8% of the expended costs. So this means that shifting left is really, really important. But what does it mean, shifting left? So in context of system modeling or model-based system engineering, MBSE, shifting left means leveraging system models. For example, the ones created in System Modeling Workbench, and simulation models very early in the design process to make informed decisions, ensuring that the majority of projects costs are committed when the cost of making changes are still relatively low. By doing so, you can identify and resolve problems before they become more costly and complex to fix later on. So this approach helps in reducing the risks, improving the quality, and saving time and money. So what has been, our MBSE strategy, right? MBSE is a cornerstone of, Siemens MBSE strategy. From left to right, it begins with defining, the product requirements and developing system models for concept designs. These models are abstract enough to guide detailed engineering while allowing flexibility for innovation and adherence to system specifications. We support system modeling by integrating with leading tools like Rhapsody, Capella, and Cameo, right? Capella being System Modeling Workbench in our case. Also working on a SysML v2 next generation. At the center of our approach is merging requirements, goals, objectives, and system models with our lifecycle capabilities, and a common information model. These common information models ensures that all engineering domains consistently use the system definition data, regardless from where they are coming, from which tool they have been authored. We also provide lifecycle services such as change management, configuration, traceability, integrating the engineering data produced across all the downstream domains that you can see on the right-hand side, right? To capital, to expedition, NX, running simulations in Teamcenter tools. In summary, our unified architecture streamlines design and development and supports early issue detection through the shift left strategy and builds a digital thread for traceability from concept to implementation. This comprehensive documentation and change analysis facilitate informed decision making, all powered by Teamcenter as the digital backbone. So what is the Teamcenter MBSE offering, right? So as you can see on the left-hand side, there is 5 main pillars: requirement management, test verification, parameter management, system lifecycle management, right? And the ability to view your product, including the system data, through a digital thread. These main pillars have been combined into 3 prepackaged MBSE solutions. Essentials. Basically, this is where most of companies starts by defining requirements, right? The standard prepackaged include also test verification and parameter management. And the advanced prepackaged solution adds on top of it, system lifecycle management. This is in this configuration where the system modeling comes into the picture. System Modeling Workbench is then an add-on on top of the prepackaged MBSE solution Advanced, right, to design system definitions and manage them in Teamcenter. I'm very pleased also to announce that the System Modeling Workbench does now support Teamcenter X. And a very small parenthesis about what Teamcenter X is. It's the cloud version of Teamcenter, right? So Teamcenter X, Siemens takes care of deploying, maintaining, upgrading, the Teamcenter environment for you, right? So this is, to reduce IT costs in your site. Now, these products can also be purchased a la carte, right? The prepackaged solutions provide a easier access to to the different levels of MBSE, but still they can be purchased a la carte. So today we are going to explore System Modeling Workbench integrated with Teamcenter in 4 main I would say benefits or capabilities. And the first one, we will see that System Modeling Workbench now integrates with Teamcenter Product Configurator. It integrates also with Teamcenter Supplier Collaboration. Right? We will discuss about early architecture optimization and verification and what the benefits are. And finally, we'll go through the benefits of doing a multi-domain engineering integration. So let's start with the first one. Right? SMW integrates now with Teamcenter Product Configurator. And why? Because when product variants are integrated into the system architecture from the beginning, it ensures that all the configurations are consistently considered. This leads to a more cohesive, detailed design process, reducing the risk of inconsistencies and integration issues later on. So let's look at the process. Teamcenter Product Configurator establishes a common multi-domain definition of product variability across the entire product lifecycle. Right? This is what you see on the top. The variability could be on the product lines, models. It defines families, features, constraint conditions, and the single product variability definition is consistently reused across all the steps or the phases of the product definition. It manages a range of configurations within a single variant backbone, right? Connecting product variants seamlessly from product planning on the left throughout the execution and services. What are the benefits of integrating System Modeling Workbench with Teamcenter Product Configurator? Well, early definition of variants and options facilitates the reuse of components and systems across different product configurations and platforms. Right? So this ensures that allows a better resource allocation and reduce the cost overruns. It also enables or allows for comprehensive testing and validation of all the different configurations. This ensures that potential defects, that could be related to one of the configurations, are identified very early and resolved. Also, understanding the different variants early helps in accurate cost estimations and budgeting. So this allows for better resource allocation and reduces the likelihood of cost overruns. So let's see a demo of how System Modeling Workbench integrates with Teamcenter Product Configurator. So listening to our customer feedback, an aircraft manufacturer introduced a new cloud-based entertainment service, allowing long-haul travelers to stream newly released Netflix, for example, series during their journey. To optimize operational costs, this service is selectively deployed on long-haul flights, business jets, government VIP aircrafts, and premier airlines. However, it's not available on low-cost carriers, cargo planes, or military aircraft. This product variant configuration is then saved directly within the system architecture in System Modeling Workbench. Within System Modeling Workbench, the system designer then select and apply a configuration to the model. SMW then filters the diagrams, removing the system elements that do not apply. In this case, the cloud media server is removed. The designer can navigate through and apply different configurations to validate the project model. The system designer publishes then to Teamcenter the 100% system architecture and 150% architecture to enable a seamless and consistent transition to downstream teams that will perform the detailed design. This leads to a more cohesive detailed design process, favoring reuse and reducing the risk of inconsistencies and the integration issues later on. Let's look at the second capability that we wanted to share with you today. It's the capability that SMW can work with Teamcenter Supplier Collaboration. So why we did this integration? Well, Teamcenter Supplier Collaboration facilitates seamless communication among all the stakeholders working in a given system project, including suppliers. So this ensures that the OEM and the partners are on the same page and can collaborate effectively. This integration not only improves operational efficiency, but also drives innovation and competitiveness. So Teamcenter Supplier Collaboration, what it is, right? So Teamcenter Supplier Collaboration is an application on top of Teamcenter Foundation. It offers a secure, a seamless, and a flexible solution to collaborate with your supplier chain. It offers two approaches. The first is Partner Connect. Partner Connect offers a simple and secure approach to invite suppliers into your Teamcenter environment. While you do this, you can set a time-bound access to the data by suppliers and based on the project needs. The second approach is to use Supplier Connect. The solution provides a portal-based approach to access the data. It offers flexible data sharing approach where suppliers can edit the data live through the tools integrations. In that case, System Modeling Workbench integrated with Supplier Connect, or even edit data offline through Briefcase. Suppliers can also initiate a request for data, right, using the portal self-service. So what is the benefit, right, to integrate System Modeling Workbench with Supplier Collaboration? Well, partners often have specialized knowledge and expertise in specific domains. So by involving these partners in the design of subsystems that play a big role in complex systems, well, you can tap into their skills and insights, leading, in that case, for more innovative and effective solutions. Early collaboration with partners can also significantly shorten the design phase while you focus on the system and delegate to partners the design of subsystems, right? You accelerate and shorten the design phase. Partners can also bring fresh perspectives and innovation ideas to the table. So it leads also to advanced and competitive subsystem designs. So let's look at a demo of how, in that case, an aircraft entertainment system manufacturer collaborates with a supplier to design the architecture of the new media cloud-based service. So first, Ed, the OEM system architect, he creates a specification package for the cloud media server component that he will hand over to the partner. He creates a subsystem black box, specifies the external interfaces, the exchange items, associate the requirements of the subsystem that he must satisfy. He provides access to the partner by assigning a partner contract to the cloud media server project. So this partner contract or contact, can have limited duration. So you can set a time box, let's say, of 3 months, 6 months, after which the user will lose the access to the, your IP. Sally, the partner architect, in that case, can access the project model from the very same source, right? So she gets, the system definitions, and then she can create the cloud media server architecture complying with the interfaces specification from the OEM, from head, right? The updated architecture is then published back to Teamcenter. Head, in this last step, synchronize the subsystem architecture that has been updated by her partner. He used Teamcenter chat, for example, to share feedback or markup annotations to provide feedback to Sally, to the partner. Right? So both OEM and partners are collaborative working within the same environment, using exactly the same data. And thanks to SMW concept of decomposing a system into subsystems, in a subsystem project or in a library, so that only part of the system data or IP can be shared with partners. Let's look now at the third capability we wanted to share with you today. So it's the execution and of early architecture optimization and verification. So again, System Modeling Workbench integrated with Teamcenter, enables architecture optimization. So this enables early identification and resolution of design issues. It enables optimizing the design early, and this is going to help in managing costs more efficiently. So let's look at the process. So the process to perform early architecture optimization begins with the conceptual design phase, where system requirements and model mission scenarios are defined. Mission scenarios describe how the system will be used in a real-world situation. It helps in understanding the operational context and potential challenges. This phase, the conceptual phase, includes developing also functional models and system architecture in SMW. The second phase in that process is to run architecture exploration and MDAO. The inputs to this phase are the architecture functions, the subsystems, interface definitions, exchange items, parameters, right? Teamcenter IDS then explores different architectural options to find the most effective design. It helps in identifying the best configuration that meets the requirements. It integrates also, with simulation models from various engineering disciplines to analyze and optimize the design. It ensures that all aspects of the system are considered and balanced. Now, the good thing of it is it can iterate on thousands of concepts to optimize the system architecture, and all of this automated. The outcome of this phase is an optimized product architecture that satisfies product requirements and the mission scenarios. This optimized architecture can then be used for preliminary designs. What are the benefits? Well, early identification and resolution of issues. Also, optimization of the design early helps in managing costs and more effectively. So let's look at a demo on how a braking system architecture created in System Modeling Workbench can be optimized by running a design analysis and an optimization with Teamcenter IDS. The next video, this demonstration, has a voiceover.
The first step in this process is to allocate requirements defined in Teamcenter to the relevant system component. Here we see this done in the Teamcenter system modeling environment using drag and drop from the integrated Teamcenter browser. Ed, the systems engineer, has now built out the component further, linking other requirements and defining design parameters and ranges. This provides a holistic systems engineering view, and we can see that a number of design parameters are needed to describe the brake discs as the outputs. Some analysis is needed to select the brake disc characteristics, so Ed selects the relevant system parts and the requirements being targeted and creates a new optimization study to explore the possibilities. Ed sets out the scope of the study by selecting the parameters he wishes to vary, reviewing ranges and resolution, and focusing on the geometry of the cooling channels. In this step, Ed uses the requirements to set objectives and constraints of the study. This allows rotor temperature, braking distance, and system cost to be minimized, while meeting the requirements on all three parameters. With the optimization study defined, he passes it to his colleague Sam, a simulation engineer, via a workflow in Teamcenter. This ensures that Sam has all the data she needs to build the study, while also providing traceability for other stakeholders. Sam opens her task from the Teamcenter homepage and familiarizes herself with the task. System architecture, requirements, parameters, and verification activities are all connected. By reviewing the associated diagrams, she understands which simulation models are needed to explore and verify performance of the braking system. After a final review of the study parameters, she opens the Teamcenter MDAO environment directly from Teamcenter to begin setting up the analysis workflow. The study parameters are automatically passed to Teamcenter and identified as variables and responses. Sam adds a simulation step using Teamcenter, using a parameterized 3D thermal model of the rotor and caliper. The model is automatically inspected, and input and output parameters extracted. The next step is to connect these to the study parameters and responses. She searches for the relevant values in the simulation model and tags them accordingly. To calculate the overall cost, she adds a second step to the workflow, using an Excel spreadsheet. This function takes the mass calculated by Teamcenter and computes a cost metric, which is also included in the study responses. Once fully set up, the MDAO project is saved back to Teamcenter. Next, Ed will execute the optimization study created by Sam and review the simulation results. He runs the study interactively, which provides him with continuous feedback on progress. Teamcenter's intelligent optimization algorithm explores many different designs to learn the relationships between variables and responses, while driving towards the study objectives. Back in Teamcenter, Ed can immediately see that the best design found provides output parameters which are all within their targeted ranges, and these are automatically verified against the requirements originally defined. A benefit of this fully integrated and traceable approach is that input and output parameters are tied to a particular design revision. If any changes are made elsewhere in the design which impact on this component, it is fast and easy to repeat the analysis and optimization with updated data. In this case, the product cost requirement is reduced from $6 to $4.50. This is below the cost of the current design, so the optimization study needs to be repeated to find an alternative design candidate which is cheaper to produce. Once the requirement is changed, it is flagged as unsynchronized in the optimization study. Ed synchronizes the requirement and parameter and looks for cheaper design candidates by expanding the parameter ranges used in the optimization step, based on insight gained from the previous design iteration. Now the second optimization can be executed by reusing the existing study setup. Ed launches the study for a second time, and now we see the optimizer following a different path to find designs meeting the updated, more stringent, requirements. Back in the system modeling environment, Ed uses the integrated Teamcenter viewer to access the latest optimization study and the resulting design parameters. This information and the status of the verification is visible to all stakeholders. In this case, all requirements were passed by the design selected. Ed returns to the system model and synchronizes the design parameters with the latest verified values. His model is now up to date.
Okay, so as we have seen in this capability, it's this closed loop enables, optimizing the architecture and getting back into System Modeling Workbench the result of the optimization. So let's look at the multi-domain verification integrated with simulation. Right? That's an important step as well. And the story is the aviation sector. In that example, emits close to 1 billion of tons of CO2 per year, right? And the emissions would even double by 2050. Right? During the same period, the ATAG group, the Air Transport Action Group, committed a 50% CO2 emission reduction compared to 2005, and the European Union set with the Green Deal a target to become a carbon neutral. So multiple options are being evaluated. One of them is to use hydrogen propulsion with an hybrid engine, and this could significantly reduce the climate impact. So on the left of this process, we see the initial phase where we define, these new requirements. We define the key parameters, the test cases for the aircraft system running with this hybrid engine with hydrogen propulsion. The system engineers define the key scenarios and their key parameters, like the fueling time, the range. These parameters are then centrally managed to be consumed by different virtual verifications activities. This step sets the stage for a thorough verification process. Using the hydrogen propulsion with hybrid engine introduced many challenges, but we are going to focus only on the liquid hydrogen storage. Let's assume we must integrate the liquid hydrogen tank in a current aircraft fuselage and wing. What could be the issues? Right? Refueling with hydrogen impacts the fluid network. Will we be able to achieve the maximum refueling time with the storage design? Will the temperature and pressure of the hydrogen support the heating variation? The mass of those tank needs to be as low as possible, but will very thin designs last for at least 20,000 takeoffs? Should the cooling control system be redesigned? And also, how to ensure that the highly explosive hydrogen storage tank is safe and reliable throughout the functional hazard assessment. On the right, we explore the multi-domain verification with simulation. Right? This includes verification of the cooling control system in, for example, MATLAB Simulink, the safety analysis of this new hydrogen system in MADE, and fatigue analysis in AMISIM. We can continue the verification with flow and the heating analysis in STAR CCM Plus tools. Each of these multi-domain verification is crucial for ensuring that the system meets the performance, the safety, and the reliability targets. Right? So to be noted is the variety of tools in the Siemens portfolio, right, to run system architecture, validation, verification across multi-domain engineering. So let's look at an example. So we will look at an example of doing a failure hazard analysis in PHM Mate. Right? So this is a new integration that is going to be released in the next version of Teamcenter 2506, where the system definition as created in System Modeling Workbench can be imported into MADE to run the failure and hazard analysis. So here, HEAD has published into Teamcenter, the project model, the IFE system model. Now, Sally in MADE is importing the system model. She is defining, an FHA profile, defines phases and segments. She's going to define as well the mission profile, the safety criteria. She's going to define the failure, the safety criteria. She's going to define, the range of these criteria. She's going to define the, the criticality of each of these conditions. Once the failure analysis has been completed in MADE, MADE is published back, the results of the failure analysis into Teamcenter and trace them back, to the system definition. So from the system definition function, you can navigate through the failure conditions, the failure modes, and see, the mission states, the safety criteria, and so on. So a full end-to-end traceability. Finally, the fourth, capability wanted to share with you today is the multi-domain engineering integration. So as we have seen until now, right, we have built a system architecture, system definition, we optimized it, we verified it through different multiple verification cycles, right? We do have now an optimized and verified architecture. So now we have in Teamcenter, the single source of truth for the system architecture, a blueprint of the system model, which can be used consistently across, the various domains that are going to detail, the design of the product. So let's look at, this process, right? So on the top left, as we have explained, the system architecture is now completely defined, verified, and optimized. Domains like software, like electrical, can then consume the system definition or part of it, right, for detailing the architecture in their domains, doing a software architecture, doing EE architecture in capital system, or software architecture in Rhapsody, right? And then re-execute a set of multi-domain verification with the multi-domain. So let's look at this example. We have an angel wall to detect fires, and there is a new request to integrate a camera to automatically detect fires. Right? So a new camera is being added to the system. So let's see how does it impact, all the downstream applications doing detailed design. Again, in System Modeling Workbench. So in that case, the angel wall fire detect system, right, is going to reference, the system requirements and parameters. Very important, for the multi-domain design, detailed design, and verification. So the updated design is published in Teamcenter, and new design analysis to verify, the impact of the new camera that has been added is created. And this request is submitted to a workflow, so all the stakeholders working on the system can initiate the design analysis. In that example, it's an EE architect that gets automatically from Teamcenter the system definition that includes the new system element, the camera, and verifies the impact to the EE architecture. You realize that, adding this new camera is going to require a new bus to exchange, the data between the camera and the controller. In that case, this integration, this capital integration with Teamcenter, right, is something that is going to be released also in the next version of Teamcenter 25.06, right, and gets automatically, the system design from Teamcenter. No need to recreate manually, which is error-prone, right, the design in capital system. Okay, I would like to, conclude, this session today by exploring additional usability and more features we did in System Modeling Workbench in the past releases. Right? So from top left to right, in 24.06, we in the release of June last year, we added to the digital thread the operational analysis, so that the requirements can be linked to the operational analysis, to operational processes, and that have them participate in the overall product digital thread in Teamcenter. We also enabled to configure the direction and the type of relations between requirements and the system elements. Right? So System Modeling Workbench offers a robust mechanism to configure the relationships between requirements and the model elements. For example, the relationship type between a requirement and a function may differ from those between requirements and the behavior component or function, for example. Right? So it's also important to note that your Teamcenter relationship rules can enforce the direction of these relationships. So System Modeling Workbench now offers a comprehensive set of configuration options for requirement relations, including various types of directional rules. So within the integration mapping, you can specify rules for each modeling element type, what types of relation they apply to, and their associated directions. So this provides a more flexible way of linking requirements and parameters to your system elements. We also added custom properties mapping. Right? So we understand and we heard our customers that custom properties are added to the system definition, right? And they need to be mapped to Teamcenter properties for downstream consumption. We also added, or improved the organization of model elements in Teamcenter by model packages. So the way they have been organized in System Modeling Workbench, this organization is preserved when the model is published into Teamcenter. This makes much more easier, the design reviews within Teamcenter. All the elements fall in the same place. We also improved, the security aspects by assigning a Teamcenter project to the project model at the time the project model is published into Teamcenter. Right. So now directly from within System Modeling Workbench, you can select, and assign one or more Teamcenter projects, so that only the group, the roles that need access to the project really, can access it. And not least is in the last release, we improved significantly the way to deploy the System Modeling Workbench integration with Teamcenter. Right? Now it's much more easier, all integrated in the System Modeling Workbench installer, no middle tier needed to enable the integration with Teamcenter. Okay, so just to be proactive, you may have a question about the new SysML v2 standard, right? So yeah, while we are working on a SysML v2 solution, be sure that we remain committed to System Modeling Workbench, right? And the proof is, all the new capabilities we shared with you today, right? We are committed to, augment the business value and the value proposition of System Modeling Workbench to our customers. The maturity of the SysML v2 in the market will evolve as more organizations implement it, and as tool vendors develop the compatible solutions. Also, the differences in the language and methodology between System Modeling Workbench and SysML v2 are significant, and so any transition to SysML v2 must be justified with compelling business reasons. Right? So, if you have a project which mandates the use of SysML, or you have a high interaction with customers or suppliers, and SysML is mandatory, right? Then maybe this transition make sense, right? Otherwise, leverage the investments you already done or you plan to do in System Modeling Workbench.
Thank you very much, Albino, for this very clear and thrilling presentation. First, do suppliers need to have System Modeling Workbench in order for the collaboration to work, or can they be using any other MBSE tool?
Yes, suppliers will need to use System Modeling Workbench. The collaboration is based on this Capella capability to decompose the system into subsystem projects or libraries. So the demonstration you have seen, the subsystem has been defined in a sub-project or in a library, and the supplier is directly accessing it and opening it in System Modeling Workbench. So the answer is yes, SMW is needed.
Next question then. Is there any plans to extend SMW to also have SysML v2 modeling support?
Yeah, so as mentioned in my last slide, right? So SysML v2 language is still maturing, still being used by customers. System Modeling Workbench will remain right based on Capella and Arcadia methodology. So a SysML v2 tool would be another tool other than the System Modeling Workbench.
Next question then. How does your architecture support concurrent collaborative modeling from multiple engineering domains without data integrity issues?
So this is achieved by the integration of System Modeling Workbench with Teamcenter, right? So design iterations, design changes, because of closed loop feedback coming from engineering domains are implemented in System Modeling Workbench, but then published into Teamcenter, which is going to host the blueprint of the system definition. Then all the engineering domains will reuse the exact same version of the system definition, which avoids data integrity problems.
Then how does SMW enable model validation through simulation? You showed it a bit. Can SMW models be validated by integrating their MBSE data with other simulation tools?
So as you have seen in the videos or the demonstrations, the answer is yes. I mean, System Modeling Workbench models can be simulated, right, using the various products in the Teamcenter portfolio, right? The process is not peer-to-peer integrations, but to go through Teamcenter for simulation. Right? This ensures that the simulated designs and the result of the simulated designs are consistent with what has been published into Teamcenter. Right? Then from Teamcenter the results can be synchronized back into System Modeling Workbench.
Does TC have integration with Polarion, and if so, how can that be achieved?
So does TC has an integration to Polarion? The answer is yes, at the requirement level. So there is a Polarion Teamcenter direct integration, which enables publishing requirements for Polarion into Teamcenter, so that the complete product in Teamcenter have traceability to also software requirements that have been created in Polarion. That this integration do not synchronize any system architecture elements. It's only requirements.
Then the next question: what is your strategy for maintaining interoperability as these external tools evolve or their versions change? So
if we talk about the interoperability between System Modeling Workbench and the domain engineering tools to do detailed design or to do simulation, right? The strategy is to always go through Teamcenter. Teamcenter is going to abstract any tool format or APIs changes. Each tool is going to be validated against the same set of Teamcenter versions. And as Teamcenter is going to evolve, they will be certified as well. Right?
So a question related to product configuration, obviously. Can we build product configurator families, groups, features based on parameters from parameter management?
Yeah, this is a good question. The answer is no. Product configurator families and and groups are different from parameter management. Parameter management are really for the MBSE system definition or to parameterize requirements for validation and optimization.
How does Supplier Connect enable model data conversion between OEM MBSE solutions, for example, SMW or Cameo, to the supplier MBSE solution or any other similar solution? I believe that's the same as the first question, isn't it?
Yeah, it's close to the same. And so just to be clear, Supplier Connect do not do any translation or any conversion from a model language to another language. Supplier Connect is a platform to enable an OEM to share some data, the data that is required for a supplier to implement or to simulate part of the system. So Supplier Connect is enabling collaboration, discussions, right, data sharing, but not model data conversion.
When sharing through supplier collaboration, how can we hide or make visible only relevant parts of physical architecture from SMW?
Right. Yeah. So this is done by decomposing, the system into subsystems. And if you need a supplier to work on a subsystem, create a Capella library or a Capella project, and use the record and replicas concept, right, to inject into your main model, these reusable components. When you publish to Teamcenter the project, the libraries are also published into Teamcenter. Then you can choose which of these subsystem projects or libraries you want to share with your customer.
Then, does the Teamcenter variant integration have any correlation to the pure variance connector?
No.
Will Supplier Connect work between OEM and Tier 1 if they are using different MBSE solutions and PLM solutions?
So if they use Supplier Connect, Supplier Connect works with a portal, so they will be able to access the data. So it does not require to have the same PLM solution. Now, in terms of system modeling authoring tool, this is where the data conversion could be a challenge. But if both supplier and the OEM use System Modeling Workbench, then it's not a problem. They can be using different PLM solutions.
How does Siemens ensure secure yet efficient model sharing when multiple suppliers collaboratively edit models, both live and offline? Yeah.
Right. So this is following the same strategy as explained before, right? Decomposing the system into reusable components, into subsystem libraries or projects. Each supplier will have a single supplier will have access to this particular subsystem.
And a question recently upvoted is this one: SMW and Capella are two different tools, right? If yes, if I start currently with Capella, can I import my work from Capella to SMW?
Mm-hmm. Yeah. So SMW embeds Capella. Basically, it's Capella with multiple add-ons on top of it, right? So if you start with Capella, yes, you can later on move to System Modeling Workbench, right? Again, SMW provides additional add-ons like out of the box the system transition requirements and so on, and also the add-on to integrate with Teamcenter and interact with Teamcenter. So the model itself are the same.
Thank you. So just a detail, which version of SMW, Active Workspace and Teamcenter are being presented through the functionalities today?
So what you have seen is Teamcenter 2412, SMW 2412. Some of the functionalities that have been described, they are available since several releases of System Modeling Workbench. What is new in System Modeling Workbench 2412, for example, is the product configurator integration. The made integration is also in 2412. The other ones are already available since 2 or 3 releases. there is a compatibility matrix that describes exactly which capability has been made available in which SMW version.
Let's go for the last question. I believe this is Vincent again. Siemens SysML v2 solution is based around a specific methodology. Will it allow incorporating Arcadia?
So that's something that is being discussed and analyzed. If it will include the Arcadia methodology, it might be done in multiple steps. But at this point, it's just analysis that is ongoing. No decisions made yet.
Okay, thank you very much, Albino.